Hello! As promised, I said I would help show you how to draw a fuel oil diagrammatic. And I started off by setting up a couple of pieces on my diagram. And you can do this for your ship. I showed that I only had four fuel oil bunker tanks. You would put in as many tanks as you want. So if you had 3 or 4 tanks per side, you can separate them. But I just thought this would work for clarity. So I have 4 tanks. I just depicted the fact that they're not all the same size because that doesn't really make any difference. And eventually I want to move any fuel that's in these storage tanks either to each other's storage tank or over to the settling tank. Now the day tank is over here, which I put in, and I'm only showing one settling tank for simplicity. If you wanted to do 2 settling tanks, that's okay. You just tie it all in. Now the whole idea to my logic diagram is to use a very important piece of equipment called a manifold. So right now I just drew this small block as a manifold, and I'm going to quickly show you how a manifold actually works. So a manifold is a piece of equipment that is designed, purpose-built for every application. And basically it would look like a block of some sort. Now, of course, there's many different types of manifolds. But the one I'm showing you is a block, which I'm depicting here. So what this block would look like, specifically if you looked on this side, it would have the division, okay? And the division on the top would be like this. So it's like a top and a bottom half. So down here, if you can envision, this is a large pipe, and this pipe fills up with fuel. Up here, there are small valves. So however many valves you have, this would be divided into. So in my case, I'll just show that I've got 3 or 4 valves, okay? So all of these little lines here would be indicating that these are valves, and they would be separated. So what would happen here is you would have a spindle here, and possibly a spindle here, and another spindle here, and another spindle here. So this would be all the way through, and of course you'd have them on this side. One side would be considered suction, and one side would be considered discharge. So what would happen in real life is fuel would come in to the ship through the bunker lines, and it would go into this larger area. And this larger area would eventually fill up with fuel. Then, depending on what valves are open, so if I'm discharging this fuel, I might want to open this valve here by turning the spindle, and whatever pipe was connected to this, fuel would leave this area in the bottom and move out through. Okay, so that's how a manifold works. So what I've done in this diagram is I'm showing a manifold. So you might be wondering, how many blocks do I need to fill in my manifold? So what you would do is you would always have, in my case, I'm going to have 1, 2, 3, 4, plus one more as 5 blocks in my manifold. So I'm just going to divvy this up, 1, 2, 3, 4, and 5, okay? And just for clarity, I'm going to put in my suction and discharge. You don't have to do this. This is just showing you how it goes together. So how this works now is you would have to put, attached to the manifold on this side, a set of pumps. So I'm just going to draw 2 pumps, because these will be my transfer pumps. And I'm just going to depict them as positive displacement pumps, and I'm going to indicate that they are flowing in that direction. It's very important to put flow direction on your diagrammatic. So on this pump, right after it, I'm going to put a valve, and the valve I'm going to put there is a screw down non-return, so nothing can go down. Actually, it would probably be just a non-return, not a screw down. So I'm going to depict it like this. Okay, and there's my non-return valve. Remember, if you can't remember what symbols you're using, look at your pipe symbol chart. Okay, so then I'm going to draw a line like this. So I'm connecting both of these pipes, and I'm just going to put little dots where I have junctions, just so you guys can get familiar with it. Now, I'm going to indicate that on this pump, we are going to connect here. So the direction of this is any fluid that's coming into the pump would go in this direction, come up through here, come up through here and go to the discharge side. Now remember, because this is a manifold, the flow can be directed in through this internal part. So even though it might be directing it here, I can actually suck it out through this side and move it through any of these other tanks. On this side of the pump, I'm going to put in a gate valve. Okay, so this would be an isolation valve so that I can isolate the pump and do repair on it. So once again, I'm just going to connect it all in here, like so, and I'm just putting these dots in here so you can see that these are junction areas, okay? All right, so your manifold typically has the X's in it to depict that these are gate valves, so they're either totally open or totally closed. Okay, so how do we get this work? This is the basis of our fuel oil system. So what we're going to do is indicate that up here somewhere are a set of pipes that are going to be bunkering lines. Now, on the top of the bunkering lines, you would have one for port and one for starboard, so you always have two. You normally have valves to indicate which side would be open. You would have a junction, and this line would come down and it would feed directly into the manifold. So normally this would only have one direction. So we're taking fuel on, because this kind of ship could be using bunkers only for its own, not for dispersing fuel to anyone else. In this case now, we want to connect up these other setups. So what I'm going to do, and this is just something to help you, you don't need to finish your diagram like this, but I'm just going to say 1, 2, 3, 4. My settling tank is going to be number 5, so I'm just going to put little numbers there, 2, 3, 4, and 5, so I don't make any mistakes. So first of all, I know that I am going to tie in this pipe, this manifold, into this tank. Now, normally on a fuel tank, you will see another valve up here that's usually right on the tank. I'm just going to put a little squiggly mark like that, because that would be considered a quick close valve. And the quick close valve will allow, if there's any fire or any kind of things like that, so that fuel will not move out of the tank. I'm going to put that same valve right here on each of the other tanks. Okay. And now I'm going to connect up these lines. So I mentioned the little numbers. So fuel oil 1, I'm going to connect up with this part of the manifold. Fuel oil 2 is going to come out and connect in with this one. Fuel oil 3 is going to connect up with valve number 3. So I'm just going to draw something like that. And then fuel oil 4 is going to connect in. Now, when you are looking at the direction of these pipes are designed to do both suction and discharge. So you have to calculate them and usually take the bigger of the two. When you look at the calculations, you'll see one flow velocity for suction and one flow velocity for discharge. Calculate them both and then put the size in. These pipes would then be able to put flow directions of both suction and discharge, because the manifold is going to do all the work and tell us whether it's flowing from here or here, and of course the pump is going to tie that in. So once again, you're showing flow direction in both directions. Okay, so I'm just putting in those direction arrows and just indicating here which way these things are going. Okay, and same thing on the settling tank. All right, so now we've basically got the crux of our diagrammatic or logic diagram put together. A couple of things you want to put in with this is also, how does fuel get from the settling tank over to the service tank? That has to go through a purifier. So I'm going to just little purifiers. These are symbols for purifiers. Remember, of course, in a diagrammatic, you would put all your symbols over here in a chart. Excuse me. Now, fuel would come out of the settling tank, go into one of these lines. Of course, there's two there, potentially for redundancy, sorry. So you would have redundancy on both. They would require isolating valves. and an isolating valve here. And then the pump and everything to move this is actually part of the purifier. So then this would leave here and feed into the service tank, and we'll just connect these up here. So the direction of flow for this is this. Okay, so it comes out of the settling tank and into the service tank. If you fill up your service tank and you were afraid that it was going to overflow, one of the places you would design an overflow pipe is up here so that any fuel could flow directly back into the settling tank. This would give this direction. Sometimes there's a check valve on this, so I'm going to put a check valve on it so that it can't go back that way. And normally there's an alarm on that as well. But that's another separate setup. Another piece that you want to look at is the fact that all of these tanks would have vents. Okay, so I'm just going to draw these lines as vents, and I'm going to put this out here. Sometimes the vents, when you're looking at the rules for design, the vents are normally called air pipes as well. They are put in, and they're just looking like that. These pipes would eventually have pieces on it with so water, like a ball set up so water can't get back into it. So you can show your fuel pipe vents like this, or your fuel tank vents like that. Okay, so now we've got all the bits and pieces together. We got our direction and how everything is flowing. So I want you to get an idea that if I wanted to take fuel from this tank and move it into the settling tank, I could open this valve here on the suction side of this tank. The pumps would be, one of the pumps would be turned on. The pump would take fuel from this side of the manifold, move it up into this direction, move it into this manifold, and then eventually put it into the settling tank. When we look at the sizing of these tanks, to finish off a diagrammatic, we need to have some pipe sizes. The pipe sizes I'm going to use, I've already calculated. I'm going to say that they are 200 millimeters for the bunker lines. So I would put my pipe size on the top and also to the left. The pipe sizes of the bunker lines are the biggest sizes possible system, which means the transfer pipes would all be smaller. In my case, I'm going to say that these are 80 millimeters, and you would design that based on the size of your transfer pump. So this one would be 80 millimeters, this one would be 80, 80, 80. All of them would else be 80, okay? Now, the pipes going into the service tanks are usually considerably smaller because they come through the settling tank, work through the purifier, and then move. This is steady operation generally on the ship, so these pipes would be smaller. In my case, I'm just going to make them 20 mil pipes or 25 mil pipes. I'm not sure if the standard is on that. This information would come from your purifier standard. You can just put in a standard 30 mil, 25, 40 mil pipe, something small that would go in there. But one of the things you do have to take into consideration is that the pipes going in, and we'll look at the settling tank specifically. So if this pipe was going in at 80 millimeters, this air pipe has to be larger. And the air pipe is normally one pipe size up. It's actually supposed to be 25% of the area. So in this case, this vent would actually be a 100 millimeter pipe. So the air pipes are always bigger. Normally, the overflow pipes are bigger as well. So if I had, let's just say I got a 25 going in here, then this one would probably be 40 or bigger, and I should put that on the other side. Anyway, I hope that helps you with creating your diagrammatic. Thank you for listening, and I'll look forward to seeing your work when you submit it. If you have any questions, by all means, please email me. Take care.